In last lecture, we discussed the numerical related to the viscosity determined from the velocity distribution equation and also determine the velocity gradient. Velocity gradient, alternative name for the velocity gradient is the
velocity distribution.
Velocity distribution. Now today we discuss the numerical is based on the same type, slight different, that is a plate 0.025 mm distance from the fixed plate moves at the velocity speed 60 centimeter per second and required the force of 2 Newton per unit area, that is 2 Newton per meter square, to maintain this speed. Determine fluid velocity between the plate. We can see the figure. In this figure, the lower plate is fixed plate and upper plate is moves with the velocity u 60 centimeter per second. 60 centimeter per second is the velocity of the upper plate, and this plate is having distance 0.025 mm from the fixed plate. Okay, we need to determine the viscosity. We need to determine the viscosity between the plate. Whatever the fluid in the between the plate, we can find out the viscosity of that liquid. And to maintain the speed 60 centimeter per second, it required how many force? Value of force is required to maintain this 60 centimeter per second speed. How much the force is required? Aniket, how much the force is required to maintain this speed?
2 Newtons, sir.
2 Newton per unit area. Force 2 Newton per unit area. That is a 2 Newton per meter square. This much force is required to maintain the speed. So from this numerical, first step of any numerical is the write the given database. What is that given database is mentioned in the numerical? Distance. Distance means which notation we need to write?
dy, change in distance.
Or we can write the change in distance. Change in distance, or we can write the in the symbolic representation dy and its value 0.025 mm. Okay, and next value is mentioned as a moves at 60 centimeter per second. It means velocity.
Change in velocity.
Okay, we can write it's a change in velocity. Change in velocity, and that is by notation wise we can write du, and its value is 60 centimeter per second, and force is given. Force is 2 Newton per meter square. We can find out which term we need to find. Which term we need to find?
Fluid viscosity.
Fluid viscosity between the plate. This term, this data is given in the numerical. Just copy and write the in the given data set in this numerical. The change in distance dy 0.025 mm. Can we need to convert into SI system or not? Change in distance 0.025 mm. Is this SI system unit?
No, sir.
How to convert this mm to which conversion required? Mm to Lalit. We require the conversion from mm to which unit?
Meter.
Meter, correct. So what will be the conversion factor? 0.025 multiplied by 10 to the power which one? Meter, mm to meter. Tell me, mm to meter. Mm to centimeter is how much? 10 to the power minus 2. Okay. Centimeter to meter, 10 to the power 2. Now 1, okay, centimeter to meter. 100 centimeter means how much meter? 100 centimeter.
1 meter.
100 centimeter is equal to 1 meter. Okay. How will you convert the 100 centimeter to 1 meter? 100 into 10 to the power minus 2 meter. And in case of mm, then what will be the conversion factor? 10 to the power minus 3 or minus 2? Mm to meter.
10 to the power
Which one?
10 to the power minus 3.
10 to the power minus 3. Okay. And next term is a change in velocity. Du 60 centimeter. Okay. This 60 centimeter need to convert it into meter. So what will be the power of 10?
minus 2.
Minus 2. Correct. Minus 2 meter per second. Force 2 Newton per meter square. Here need to convert or we use the same unit? Need to use the same unit. No, convert the unit from the Newton per meter square. We can use the same unit. And then find the fluid viscosity. Which equation we need to apply? Newton's law of viscosity. Equation is Newton's law of viscosity. And we know the Newton's law of viscosity. What is Newton's law of viscosity? Tell me. Srushti, what is Newton's law of viscosity?
Tau is equal to U into del U upon del Y.
Okay. Tau is equal to mu into du by dy. Is this equation visible? What is the equation?
sir.
Tau is equal to mu into du by dy. We can call it as equation number 1. Mu into du by dy. In this equation, tau is a shear stress. Tau is a shear stress. And mu is a viscosity. Du is a change in velocity and dy is change in distance. Change in distance and change in velocity. Okay. Then tau, what is value of tau? Shear stress. What is unit of shear stress? What is unit of shear stress? Tell me.
Newton per meter square.
Okay, Newton per meter square. And therefore, whatever the value mentioned in the numerical, force 2 Newton per meter square, it means what? Shear stress. That is shear stress. So tau we put 2, mu you can write as it is. Du is replaced by 60 into 10 to the power minus 2, and then dy, what is value of dy? 0.025 10 to the power minus 3, and you can solve this and tell me what will be the calculation. What is the calculation? If you simplify it, the calculation will be You simplify it and tell me fastly. Is it same result or a different one? Mu is equal to 8.33 10 to the power minus 5 Newton second per meter square. You do the calculation fastly and tell me whether answer is same or different. Srushti, Aniket,
Sir, same answer.
are doing the calculation?
Yes, sir.
Okay. 8.33 10 to the power minus 5 Newton second per meter square. And what will be the unit in value in poise? If you need to convert this number into poise, what is the conversion? What is conversion? If you need to convert Newton second per meter square into poise, what is the conversion for poise and Newton second per meter square?
1 poise equals to
1
1 by 10 Newton second per meter square.
Okay. So what will be its value? Whatever the value coming, 8.33 10 to the power minus 5, its value in Newton second per meter square. So we need to find, suppose we need to find poise. Then what will be its value? Divided by 10 to the power, or we can simply divide by 10. Okay. Divide the same value by 10. First, we can write the unit conversion. The unit conversion is, see, this unit conversion 1 twice is equal to 1 by 10 and write it here 1 by 10 Newton second per meter square. Okay. So 1 Newton second per meter square means how many poise? Just opposite of this one. So 1 Newton second per meter square means how many poise?
10 points. 10 points.
Okay. Is equal to 10 poise. So that value of whatever the value coming multiplied by 10 multiplied by 10, so that we can convert Newton second per meter square into poise. Okay. So 1 Newton second per meter square is equal to 10 poise. So mu is equal to 8.33 10 to the power minus 5 into 10. How this 10 is multiplied instead of division? Because with this unit conversion, 1 poise is equal to 1 by 10 Newtons second per meter square. Therefore 1 Newton second per meter square is equal to 10 poise. So 10 is multiplied to the Newton per second value, and Newton second per meter square value is 8.33 10 to the power minus 5, and again multiply by 10. So that will be 10 to the power minus 4 twice. Is it understood how this value came? Aniket, Komal, is it understood or not?
Yes, sir.
Then we can discuss the next part is the types of the fluid. There are various types of fluid. Ideal fluid, is the screen visible?
Yes,
Yes.
sir. Yes.
Types of the fluid. There are the 5 types of the fluid. What are the types of 5 types of fluid flow? Ideal fluid, real fluid, Newton's law of Newtonian fluid, non-Newtonian fluid, ideal plastic fluid. And you know the Newton's law of viscosity. What is Newton's law of viscosity equation?
Tau equals to mu into
Tau is
du
equal to
by
mu
dy.
du by dy. And we can write this equation as in terms of y is equal to mx form. Okay, in terms of y is equal to mx form. And then y is equal to m into, we can call the x, y is equal to mx. In that form, m means slope, and plot the graph of y versus x. If we plot the graph y versus x, the graph passing through the origin. If we plot the graph, okay, I will show you the equation here, types of the fluid flow. This is Newton's law of viscosity. Tau is equal to mu du by dy. From this Newton's law of viscosity, if we consider this equation in different form, y and x form, how we can convert this equation to y into x form?
Y equals to mx.
Okay, just replace mu by x, this is y, and this we can replace by m, and this du by dy replaced by x in this form. Okay, y is equal to m into x, and if we plot the graph of which graph we need to plot? If we plot the graph of y
Versus
versus
x.
x, if we plot the graph of y versus x, then graph will be straight line. Straight line passing through origin.
Origin.
Straight line and passing through origin. Similarly, if we plot the graph of y versus x, then graph will be straight line and passing through the origin with the value of slope is what will be the value of slope of the graph? Slope of graph will be m. M will be the slope of the graph. Is it understood? If we plot the graph of y versus x, then graph will be straight line and passing through the origin. And slope of the graph will be m. Similarly, for as far as equation number 1 is concerned, we need to plot the graph of shear stress versus which graph? Velocity gradient. Shear stress, we can consider tau as a y, mu as a m, and du by dy as x. Understood? Is it understood?
Yes, sir.
Tau is considered as a y, mu is considered as a m, and du by dy is considered as x. So if we plot the graph of from equation number 1, so from equation number 1. This y is replaced by tau, and need to insert the rotation. Tau versus du by dy. Tau versus du by dy. Then graph will be straight line passing through the origin, and slope of the graph will be, what will be the slope of the graph?
M.
M. From equation number 1. Okay, this is equation 2. From equation number 1.
Mu.
Mu.
Slope of the graph will be mu. In the same way, you can see here shear stress. Shear stress means which notation as far as this equation is concerned? This equation is concerned. Shear stress means which notation? Equation number 1. From
Y.
equation number 1.
Tau.
Tau is a shear stress. Shear in this graph. The shear stress on y-axis. Shear stress on y-axis. And x-axis means which term as far as equation number 1 is concerned?
Velocity gradient.
Velocity gradient. Du by dy is a velocity gradient. And see here on x-axis, which term is mentioned in this x-axis? Velocity gradient. Du by dy. What is alternative name for the velocity gradient?
Velocity distribution.
Velocity distribution. And see here, this line is passing through the origin. This line is passing through the origin, and slope of this line, what will be the slope of this line? That is called as viscosity of the fluid. That is called as mu. If we plot the graph of tau versus du by dy, then graph will be straight line and passing through the origin, and that graph having the slope is called as mu. That is known as viscosity of the fluid. Understood? See in this graph, shear stress versus velocity gradient, and this line is passing through the origin and having slope is mu, called as viscosity of the fluid, and that type of the fluid is called as Newtonian fluid. Understood? What is my Newtonian fluid? That type of the fluid is called as Newtonian fluid. It follows the Newton's law of viscosity. The fluid that obeys the Newton's law of viscosity, that type of the fluid is called as Newtonian fluid. See number 3. The real fluid, the shear stress is directly proportional to rate of the shear strength or velocity gradient is called as Newtonian fluid. Understood? Here one more name is coming, shear strength. Alternative name for the velocity gradient. What is alternative name for velocity gradient?
Shear
So we have the 3 different name for the velocity gradient. 2 different name for the velocity gradient. One is a velocity distribution, and another is
Shear strength.
shear strength. So keep in mind there are 3 names for the x-axis. One is a velocity gradient, another is a velocity distribution, and another name is shear strength. And if the fluid obeys the Newton's law of viscosity, that type of the fluid is called as Newtonian fluid. Okay, it means that shear stress is directly proportional to the velocity gradient. Shear stress is directly proportional to shear strength or velocity gradient or velocity distribution. Then that type of the fluid is called as a Newtonian fluid. Okay, and non-Newtonian fluid. See, this graph is a passing through the origin, but not the straight line. We can observe this graph. This graph is passing through the origin, but not the straight line. It means that in the equation, there is a slight change in this equation. Slight change in this equation. I will show you what will be the changes in the equation. See here, this one equation, and in this equation, there will be the power. Suppose a n number, n. Understood? Is visible equation number 3? Sorry, this is equation number 3. Is this equation number 3 visible? Equation number 3, is it visible or not?
Yes, sir.
Yes,
Tau,
sir.
make the small change in equation number 1. Make the small change in equation number 1, and that small change means which change? Du by dy having power n. Having power n is mentioned here, and we know that if we plot the graph of du by dy, if we plot the graph of du by dy and shear stress du by dy, this graph you can call this as this one. See here. If you plot the graph of tau versus du by dy raised to power n, then graph passing through the origin, graph is passing through the origin, but then graph will not be straight line. If you plot the graph of tau versus du by dy raised to power n, then graph will not be straight line, but it is a curve. It is a curve. Understood? If we plot the graph of tau versus du by dy, then graph will not be straight line, but it is curve and passing through the origin, and with the slope is nu. With the slope is viscosity of that fluid is mu. Understood this graph? This one, see in this graph, the graph is non-Newtonian fluid. It means that shear stress is not directly proportional to velocity gradient. Velocity gradient and shear stress is not directly proportional. If it is directly proportional, then which type of the fluid? If shear stress is directly proportional to the velocity gradient, then that type of the fluid is called as
Newtonian fluid.
Newtonian fluid. And as far as a Newtonian fluid, graph passing through the origin and it is straight line. As far as non-Newtonian fluid, shear stress is not directly proportional to the velocity gradient. Shear stress is not directly proportional to velocity gradient. But if we plot the graph of shear stress versus velocity gradient, graph passing through the origin, but it is not the straight line. It is curve. Okay, it is curve. It may be this type of the curve, or it may be downside, upper side or downside. That is called as a non-Newtonian fluid. That is called as non-Newtonian fluid. Understood the difference between Newtonian fluid and non-Newtonian fluid?
Yes, sir.
Tell me, what is my non-Newtonian fluid? What is the relation between shear stress and velocity gradient? Is directly proportional or not? As far as non-Newtonian fluid is concerned. shear stress and velocity gradient is directly proportional or not?
Not.
Okay, shear stress is not directly proportional to velocity gradient in case of the non-Newtonian fluid, but in case of the Newtonian fluid, shear stress and velocity gradient is directly proportional or not in case of Newtonian fluid?
Yes, it is directly proportional to it.
It directly proportional to, understood? Shear stress is directly proportional to velocity gradient in case of the Newtonian fluid, but in case of non-Newtonian fluid, it's not directly proportional. Keep in mind. And we can also take the small change in equation number 1. I will show you that small change in equation number 1 again. The equation number 1 again, that small change is let this one. Just replace this term Please wait for 1 minute. Okay, is now visible?
Yes, sir.
I will take this as a equation number 2. Make the small change in equation number 2. Equation 2 is this one. This is equation number 2. And if we make the small change in equation number 2, that is plus C. Okay. And we can call it as equation number 4. Is it visible? Equation number 4. Make the small change in equation number 2. Which small change mention? Which change is mentioned in equation number 2? Small change. Addition
Add
of
C.
addition of C.
C.
Okay, addition of C. And if we plot the graph of, we already studied this part in 12th standard. It may be in a math subject or it may be in different subject. Okay, which subject we studied this one? Okay, you tell me, if we plot the graph of y versus x, if we plot the graph of y versus x, then graph will be straight line. Okay, graph will be straight line, but not passing through the origin. But not passing through the origin. Understood? Graph, if we plot the graph of y versus x, then graph will not be straight line, will be straight line, but not passing through the origin. And slope of the graph will be m, and the line of intersect will be C. The line of intersect. What is my line of intersect? I will show you in the graph. First of all, try to understood the concept in this equation. If y is equal to mx plus c, is it understood? Equation number 4. Y is equal to mx plus c.
Yes, sir.
Y is equal to mx plus c from equation number, okay, we need to change this equation number. Okay, from equation number 4. And if we plot the graph of y versus x, then graph will be straight line, but not passing through the origin. Graph will be straight line, but not passing through the origin, and slope of the graph will be m, and line of intersect on y-axis. On y-axis, line of intersect on y-axis will be C. Will be C. See here, line of intersect. See here, this line is straight line. Is it visible in this graph?
Yes, sir.
This line is
sir.
passing through the origin or not?
Not passing through the origin.
This line is not passing through the origin. Okay. It means that this obeys this equation. That line is obeys this equation. If we plot the graph of y versus x, then graph is straight line but not passing through the origin. Okay, and that graph having slope is m. This value is represent slope of the graph. And how we can find out the value of c? That c is this axis, this distance from this origin to y-axis. This distance is called as a intersect, line of intersect. Understood? Line of intersect means which term? From this origin to this one, this point, where this point is passing ideal plastic fluid passing through the y-axis, and this y-axis, this point and the origin, this distance is called as which notation as far as this equation is concerned? As per this equation number 4 is concerned, that distance means which one?
C.
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 That is called as line of intersect. Understood? Line of intersect. Line of intercept. Is it clear? Newtonian fluid, non-Newtonian fluid, and this type of the graph is called as which type of the fluid? If fluid obeys this type of the graph, is called as
Ideal plastic fluid.
ideal plastic fluid. Ideal plastic fluid. So we can write this equation in terms of the Newton's law of viscosity. This equation we can write, this equation number 4 we can rewrite in terms of the Newton's law of viscosity format. Okay. So how we can write this equation in terms of Newton's law of viscosity format?
Tau equals to mu into du by dy plus c.
Yes. So equation number 4 in terms of Newton's law of viscosity. This one. So that equation will be in the form of tau is equal to mu du by dy, and one more additional term is mentioned as a c. Clear? And if we plot the graph of, so which graph we need to plot such type of equation? And we can call this as equation number 5. And what will be the graph x-axis? If we plot the graph of tau versus, which graph we need to plot here?
Tau versus du by dy.
Yes, tau versus du by dy. Then graph will be straight line but not passing through the origin, and slope of the graph will be which one?
Mu.
This m is replaced by
Mu.
mu. Correct. This m is replaced by mu, and mu means it means
Viscosity.
viscosity of the fluid, and line of intercept on y-axis will be considered as a c. Understood? And if fluid obeys this equation, it means which type of that fluid?
Ideal plastic fluid.
Ideal plastic fluid. Okay. And then ideal solid and ideal fluid. Ideal solid and ideal fluid. One more fluid is there, Brigham plastic fluid. Birmingham plastic fluid is not shown in the graph, but that graph, I will show you that equation, which format of that equation. You can see here, we can consider the same equation. This one, make the small change in equation number 5. This is equation number 5. Make the small change in this equation, and that change is the, as we already discussed, we make that small change, and that change is make the power, and this power as n. Is it? In this equation number 6, what will be the nature of the graph? Can anybody guess it now? What will be the nature of the graph? What will be the nature of the graph if we plot the graph of tau versus du by dy raised to power n? Is it passing through the origin or not? Not passing through origin. If you plot the graph of tau versus du by dy raised to power n, and then graph will be straight line but not passing through the origin, and slope of the graph will be mu, and line of intercept on y-axis will be c. And here the graph is not shown here, but this type of the graph start from this point and here curve, same curve, whatever the graph curve is mentioned for the non-Newtonian fluid, same type of the curve start from this intercept point and there is slightly curve. The type of the fluid is called as Birmingham plastic fluid. It is not mentioned here, but we can remember that the type of the fluid is called as Birmingham plastic fluid. Which fluid?
Birmingham plastic fluid.
Birmingham plastic fluid. And for that fluid, the line is passing through the origin or not? Birmingham plastic fluid and ideal plastic fluid?
Not passing through the origin.
Not passing through the origin. Newtonian fluid and non-Newtonian fluid, the line passing through the origin or not?
Passing through the origin.
Passing through the origin. And shear stress is directly proportional to the shear strength. It means which type of the fluid?
Newtonian fluid.
Newtonian fluid. Okay. Then ideal solid and ideal fluid. See here, ideal fluid, a fluid which incompressible and is having no viscosity, is known as ideal fluid. Having no viscosity, that is called ideal fluid, but such type of the fluid is not available, not exist in the nature, and that is called as imaginary fluid. That is called as imaginary fluid, not exist in the nature. Ideal fluid. Ideal fluid means viscosity is how much the viscosity for ideal fluid?
0.
No viscosity, 0 viscosity, and that fluid is not exist in the nature. That type of the fluid is called as ideal fluid, only imaginary fluid. And whatever the fluid exists in the nature, it having some viscosity. It may be close to 0, but not exactly 0. Is it? That is called as an ideal fluid. And then ideal plastic, one more is a real fluid. Real fluid is a which possesses the viscosity and is known as a real fluid. It's having some viscosity. And in actual practice, in nature, ideal fluid is exist. Is it? Ideal fluid, sorry, not ideal, real fluid is exist. real fluid is exist. But ideal fluid is not exist in nature. Real fluid is exist in the nature. Okay. It no viscosity. It means that viscosity value is 0. Means what will be the nature of the graph? Horizontal or vertical?
Horizontal.
Horizontal means ideal fluid is located on x-axis or y-axis. Slope is
X-axis.
x-axis. Slope is 0. It means if slope is 0 means indirectly which value is 0? Viscosity is 0. Slope is 0 means viscosity is 0. And as far as this graph is concerned, it means ideal fluid is on x-axis. Ideal fluid is on x-axis and ideal solid fluid is on y-axis. The fluid which possesses viscosity and is known as a real fluid. All fluids available in the nature are called as a real fluid. So these are the various types of the fluid. How many types of the fluid?
5 types.
5 types of the fluid. Just tell me name of the 5 types of the fluid. Tell me 5 types of the fluid. Aniket, Lalit, anyone? Tell me.
Ideal fluid, real
Okay.
fluid,
Okay.
Newtonian fluid, non-Newtonian fluid,
Okay.
and plastic.
Ideal plastic.
Ideal plastic fluid.
Ideal
plastic. One fluid is not mentioned in the here, but I was told you what is that fluid?
Graham
Bingham plastic fluid.
Brigham plastic fluids.
I'll just show you the nature of that graph. Bingham plastic fluid. See this one here. Sorry, wanna make the correction here. Bingham plastic fluid. And see here this graph. Bingham plastic fluid. Straight line. Bingham plastic fluid is a straight line. Is it visible? This filling? Bingham plastic liquid. Bingham plastic fluid. And this Newtonian fluid passing through the origin. Bingham plastic fluid not passing through the origin. Okay, passing through the somewhere y-axis. Is it visible? This graph?
Yes, sir.
Just keep in mind how many types of the fluid flow. Types of the fluid. 6 types of the fluid. First one is real fluid. Okay, tell me anyone, Shrutika.
Yes, sir.
Tell me 6 types of the fluid.
Ideal fluid,
Okay.
real fluid,
Okay.
Newtonian fluid, non-Newtonian fluid,
Okay.
Ideal plastic fluid.
Okay, and one more is not mentioned in the slide, but we were discussed. It is called as. Anyone tell me?
Bingham
Bing-
plastic food.
Bingham
Bingham
plastic fluid. Bingham plastic fluid. So is this part understood? Any doubt in this part? And tell me, any doubt in this part? What are the discussion types of the fluid and numerical? Aniket, Lalit,
सर आपण ते तुम्ही बोलले बिंगम प्लास्टिक फ्लुइड स्ट्रेट लाईन नसतो, थोडा कर्व असतो, पण तिथं गुगलला स्ट्रेट होता सर.
Google, na? Okay, straight line. But nature of the graph, as far as this, see this equation is not. I will show you the in different book. If possible, I will show you.